In this lesson, we are going to be talking about science versus pseudoscience. So I'm going to give a little bit of information on what each is and then give some examples of them. So by the end of the lesson, you should be able to explain the difference between science and pseudoscience, explain what science is and what pseudoscience is. So what is science? Science is a way of knowing about the natural world. It requires empirical criteria or observable. So it needs to be something that can be seen with your eyes or heard or felt or tested in some way. It needs to have a logical argument, so there needs to be some type of good information backing this up as to why this experiment needs to be done or why it relates to the natural world. And then it needs to have a skeptical review. So it needs to be able to be argued with data, and it needs to be able to be questioned. Science does not cover matters of faith, art, the supernatural, or truth. Those are all things that we can't necessarily observe, so they can't qualify as science. And a scientific theory, this needs to be empirically tested or leads to something that can be testable. It needs to have a verified prediction. It needs to lead to reproducible results so others can double check your material. And it needs to include criteria for determining whether the data is factual, artifactual, anomalous, or irrelevant. Well then, if science is something you can see, something you can test, something you can touch, what's pseudoscience? Well, this is a collection of beliefs or practices that are mistakenly regarded as being based on the scientific method. So this is what we call false science, and it's not mean. Pseudo actually means false or fake. So when we say fake science, we're just referring to pseudoscience in a different way. It claims that it's scientific, or even at a higher level than science itself, and it fails to comply with the usual scientific test. So it doesn't generally fit the step-by-step procedures that we do with scientific testing, and sometimes the tests are not reproducible. So let's talk about some pseudoscience testing information. Pseudoscientific claims are based on non-evidential styles of belief. So they're based on stuff that doesn't require any evidence. It's just some type of faith in the belief that it's true and it's real. Many pseudoscientific claims are never tested scientifically, and sometimes that has to do with the fact that the people who believe in these things don't think they need to be tested, or it has to do with the fact that they're flying under the radar, or scientists don't want to deal with it. And then even when they are tested, sometimes the methods are pretty questionable. The conclusions can be questionable, incorrect, or falsified, or even kind of skewed in a way. And then if they do have successful results, sometimes they can't be replicated, which is something that we need to be able to do in science to prove that it is true. We need to be able to replicate the experiments and get the same results. So here are some qualities of science and pseudoscience. I'm going to talk about the science ones first, and then go through the pseudoscience. If they're right across from each other, that means they're talking about the same exact thing. So you can look at these and just kind of compare the different behaviors between each. So with science, we follow the evidence wherever it leads, no matter what. We embrace criticism. We use precise terminology with clear definitions. Our claims are conservative and tentative. They are properly considering all the evidence in arguments. They use rigorous and repeatable methods. They engage with peers and community. They follow careful and valid logic. And they change their ideas with new evidence. So with pseudoscience, they start with a conclusion and then work their way backwards to confirm it. They're pretty hostile to criticism. They use vague jargon to confuse and evade. They have grandiose claims that go beyond the evidence. They cherry pick only favorable evidence, which relies on testimonials or weak evidence. They use flawed methods with unrepeatable results. They're lone mavericks working in isolation. They use inconsistent and invalid logic, and it's pretty dogmatic and unyielding. So, as you can see, there's a big difference between science and pseudoscience, even in behaviors. So, whereas science embraces criticism, pseudoscience is pretty hostile. It's kind of like the my way or no way situation. Not it's my way or the highway. It's my way or no way. And we consider all the evidence and arguments when we're doing experiments, even if it doesn't fit what we want it to. But with pseudoscience, if it doesn't fit, they throw it out and say it's not usable data, because they only pick the stuff that they want to use. So just looking at this information, comparing them, science requires a lot of evidence and a lot of step-by-step criteria in order to be considered science, whereas pseudoscience, it's a belief, and that's all it needs to be. So now we're going to give some examples of sciences and pseudoscience, and I'm sure you've seen or heard of some of these. On the pseudoscience, I am going to talk about a couple just to give you a little bit of background information on them. So some examples of sciences. There's chemistry, physics, biology, astronomy, oceanography, meteorology, zoology, and geology. And then our examples of pseudoscience, we've got Bigfoot, the Loch Ness Monster, UFOs, psychic phenomena like channeling, astrology, and the 2012 phenomena. So the 2012 phenomenon was when people believed that the world was going to end in December of 2012. You may or may not remember this situation, and it was based off of a Mayan calendar. The Mayans had written down that something was going to happen in December of 2012, and they didn't say what. Well, someone in the world had read this and thought the world was going to end because the Mayans said something was going to happen. Well, that ended up being incorrect because it's obviously now 2019 and the world is still here. So, as you can see, with pseudoscience, it's basically just the interpretation of a belief that turns it into something crazy, something that goes viral, basically. So let's just do a recap talking about the most important parts of science and pseudoscience. So with science, you need to have observable criteria. You need to have a logical argument and a skeptical view. They need to be able to be tested and retested to get the same results. And they should be able to take criticism and use it to make the experiment better. With pseudoscience, it's based on thought with no clear evidence. Many are not able to be tested in the same way. They cannot duplicate many of the successes, even if they're retested. And they're pretty hostile to criticism, refusing to believe in others' opinions. So that was just basically the coverage of the main points that we talked about today. If you've come up with any questions throughout this lesson, write them down in your weekly journal. Otherwise, if you feel that they need to be answered before you do the worksheet, please send me an email and I will get back to you. Otherwise, have a great day.